So this is the start of the video on particle/nuclear physics, the start of the video series. Well, basically in particle physics, it's basically the study of the tiniest components of matter, which are quarks and leptons primarily. We're going to get into some of the other types later, but let's just start with the quarks and leptons. Basically, we have the up quark, which is a type of quark. There are 6 different types. They're also called flavors. Basically, the flavors just means different types. We're going to get into flavor later because it's a certain property that varies between certain subatomic particles. Now, the charge on these things is quite interesting because these particles actually have a fractional charge. You see the up quark has a positive 2/3 charge, the down quark a minus 1/3 charge, and then each, they alternate, plus 2/3, minus 1/3, plus 1/3, minus 2/3. Actually, sorry, that should not be 2/3 on the down quark. Down quark should be minus 1/3. That's just error right there. Yeah, basically it alternates between plus 2/3 and then minus 1/3. Okay, so basically when I wrote Z force, yes, basically I'm just going to use Z force for the strong nuclear force. I may just change that later anyway. So basically the quarks do interact with the strong nuclear force. Strong nuclear force is responsible for all the different types of elements that make up chemistry. And on contrast, here we have the leptons. And if we look at the leptons, one of them should be quite familiar, the electron, which is E minus for the symbol. And then we have the electron neutrino, which is a V and then a subscript E. All the neutrinos start with V and then have a subscript of the type of neutrino they are. So electron is E minus, electron neutrino is VE. Then there's a muon, which is also -1, and then the muon neutrino, which is V subscript mu, and then tauon, and then tauon neutrino. All of them have a minus. All of the charged ones have -1, and all the neutrinos have 0 because they're neutral neutrino. And these do not interact with a strong nuclear force. So the neutrinos we're going to talk about when we talk about the weak nuclear force, the other type. The 4 fundamental forces of nature. Probably should have mentioned this earlier. Were gravity, which is the weakest. Then we have, the weak nuclear force, also called the weak interaction. Then we have electromagnetism, and finally the strong nuclear force. And also another thing we should talk about is spin. Basically, all particles have spin, which is a consequence of the of quantum mechanics, the wave equation, if I'm not mistaken. So basically, a spin is the intrinsic property of all the different types of particles, and all these particles listed here have a spin of 1/2. And so let's just look at what some interesting things about the quarks. Well, actually, if we take 2 up quarks right here and a down quark, we actually get a proton. And if you know, protons, are part of the nucleus of all the elements pretty much. And now you write B the same way as you write any kind of chemical equation, with your reactants and the products. This is just 2 up quarks plus 1 down quark will give you a proton. And if you think about it, we'll have did I write this wrong? Actually, hold on one second. Here we go. I did write this correctly. Okay, so 2 up quarks, so we have plus 2/3, and then plus another 2/3, we'll have 4/3. But if we subtract 1/3, because the down quark is minus 1/3, and we're left with a proton, which is a +1. So that's what that's how the fractional charge came about. Essentially, this I think was experimentally determined first, the charges, and then I think the mathematics came later, but I could be mistaken. And then conversely, if we have 2 down quarks and 1 up quark, we'll get a neutron, neutral. Minus 1/3, minus 1/3 gives you a total of negative 2/3, and then positive 2/3, cancels out to give you 0, and hence we have a neutral particle. These are called hadrons. Quarks combine to form larger particles called hadrons, and hadrons are basically, like I said, a bunch of quarks together. And the proton and the neutron are the most stable hadrons, which probably is why they are used. Why nature has protons and neutrons as the nucleus for the atomic elements as opposed to any other kind of hadron. So this basically wraps up the introduction to the particle physics, and I'll see you guys in the next video.